Okay, so 2.2, defining the derivative. So let's just start from the top. Uh, whoops, whoops. This derivative is an expression that calculates the instantaneous rate of change of a function at any given x value. In other words, it gives us the slope of the function at a point. So, this graph represents this, right? And then from here, we can see that f prime of 1 is 2, right? Yeah, f prime of 1 is 2, and then f prime of 2 is 4, and f prime of negative 2 is negative 4, right? So if f prime of x equals 5 over x minus x, find f prime 2 and explain the meaning, right? So to find that, f prime of 2 is equal to 5 over 2 minus 2. So you plug in the 2, right? And it just equals 1/2. And then right here we have the slope of f of x is 1/2 at x equals 2, right? If f of x represents how many meters you have run, and so f of x represents how many meters you have run, x represents the minutes, describe in full sentences the following. So 8 and 1500 are the numbers we have. So x represents the minutes. So at x equals 8 minutes, I have ran 1500 meters, right? Same thing with this one. At 3 minutes, you are running at a rate of 161 meters per minute because of the f prime. It's not like at the specific point, if that makes sense. Notation for the derivatives, these are the Lagrange, I guess, notation. But yeah, it says notation right there, obviously. And then here's the Leibniz notations, right? And derivatives, this is the equation, how to find it, right? And then yeah, so a practice problem, we have this, right? So we have to find the derivative using the definition, the equation that we just saw. So this is our problem. So we plug it into this equation, right? Find the f prime, which is the derivative, as delta x approaches 0. Right here, we plug it in, and then we expand it. Limit of delta prime x, limit of delta x approaching 0. This should all be over delta x. But all we did here was just distribute everything, and then from here we canceled some of the numbers and stuff, and then we're left with this, right? And then from here we factor out a delta x, which cancels out these, and then we're left with our f prime of x, which is equal to this. And yeah.